this video lecture, we'll be solving this problem keys and rooms, which is a LeetCode medium problem. In this problem, we have n rooms labeled from 0 to n minus 1, and all the rooms are locked except for room number 0. Our goal is to visit all the rooms that we have, given that we cannot enter a locked room without having its key. That means we can only enter a room if we have the key to that room. While entering a room, we may find a set of distinct keys in it, and each key is identified by a number written on it. The number represents the room that particular key can unlock, and we can take all the keys with us to unlock the other rooms. So this is the problem statement which we have. Now what we are given, that we're given an array of rooms where rooms I represents the set of keys that the ith room has. We have to return true if we can visit all the rooms starting from room number 0, which is unlocked, or we have to return false if we cannot visit all the rooms. Fine. So let's see an example. So in the example input, will be given an array of rooms where each element represents a set of keys which are present in that particular room, while in the output we have to return true or false depending upon the condition whether we can visit all the rooms or not. Let's see the constraints of the problem. N represents the length of rooms array, or the number of rooms that we have, and we can have up to 1000 rooms, while the number of keys in a particular room may go up to 1000, and the numbers on the keys lies from 0 to n minus 1. That means the n rooms are labeled from 0 to n minus 1, and all the values of rooms I are unique. That means we cannot have same key in more than one room. Let's better understand the problem statement using an example. So here we have our rooms array of length 4, and so this represents the numbers which we have given to each room starting from 0 to n minus 1, that is 3. We can enter room number 0, and here, so from room number 0, so we entered through room number 0, and we pick our only key which this room holds, that is the key number 1, and hence the current key. So this represents the keys that we have right now. After we have visited room number 0, we have the key to the room number 1 in our pocket. Then we move to the next room, that is room number 1, and we ask ourselves, so this room is locked, and we ask ourselves, can we unlock this room? And the answer is yes, because we have the key to this room here, and hence this room is unlocked. So after this room is unlocked, we pick the key that this room has, that is the key to room number 2, and now we have key to room number 2 as well. Then we move to the room number 2, and we ask ourselves, can we unlock this room? And the answer is yes, because we have the key to room number 2 which we acquired in the previous room, and hence we can unlock the room number 2 and enter into it, and this room holds the key to room number 3, and we pick that key. Then we move to room number 3, and we ask ourselves, can we unlock this room? And the answer is yes, because we have the key to this room as well here. So we enter into this room as well, and this room does not hold the key to any other room because we have visited all the rooms of this array. Since we have visited all the rooms, that means it is possible to visit all the rooms starting from the room number 0 till n minus 1, and hence we return true for this particular test case. So that's the problem statement. So how do we solve this problem? What is the intuition to solve this problem? Let's see the intuition to solve this problem. So what is the intuition to solve this problem? How can we approach this problem? Notice that we start from key 0, that is we have the key to room number 0 here. So here let's say we store our key into some container. So initially we have 0 in this container, then we can unlock the room number 0, and since we can unlock this room, we have used our key. So we use up this key, we pull this element out of our container. So since we have used, so we enter into the room number 0, and we use this key which we have initially to unlock this room, and hence we pull this key out of our container, and now the container is again empty. So what do we get here? Again standing in room number 0, we have a bunch of keys which we can use to unlock the rooms which are ahead of us. So that means we store these keys into our container. So we store 1 and then I store 3. Then I move to my next room. So this room has been visited. Then I move to the room number 1 and here I ask myself, can I unlock this room? And the answer lies in the fact whether in our container do I have this key or not. To do so, what I will do, I will pull the key which is at the top of the container, that is 3, and then I will try to check if so. Let's see the intuition to solve this problem. So let's understand the intuition to solve this problem. Initially we have the key to the room number 0. So let's say we take a container and we store our key that we have. Initially we have key number 0 or the room to key number and or the key to room number 0. So we can unlock this room, and when we enter this room, what we can do is we can pick all these keys while this key has been used, and hence we remove this key from our container. Now I push these keys which I have at in this room into my container. So I push 1 and I push. So this room has been visited. I mark it as visited. Then so this room has been visited, and in my, let's say I take another array, let's call it visited array. So I call a visited array. So what I'm doing in this visited array, so this visited array is used to keep track for the keys that I have. So initially I had key number 0, so I marked this 0 as 1 or true. That means I have the key to room number 0. Then I entered this room which is room number 0 and I picked all these keys and put it into my container, and I marked these keys as available in my visited array. That means I have these keys into my pocket. Then I pull the key which is at the top of my container, that is key number 3. Then using this key I can only unlock the room number 3, that is this room. So I simply jump onto this room and I traverse this array, or I pick all the keys which are present in this room. But we know we already have the key number 0, that is that because we had this key initially while we started visiting the rooms. So we do not have to push this key again into our container, and hence the key number 3 has been removed and the room number 3 has been visited. So this room has been visited. Then I pull the next element from the container, that is element number 1. So I have element number 1 here. That means this represents the key or the room number which can be unlocked using this key. So I can unlock the room number 1 using this key. So I jump to room number 1 and I unlock it, and I pick all the keys which this room has. But we know that we already have the key number 3 and we already have the key number 1, but we do not have the key number 2 or the key to room number 2. So I pick this key and I mark it as visited, or I mark its presence in my visited array. That means I have this key, the key to room number 2 in my pocket, and I push it into the container. Fine. So the room number 1 has been visited. Then I pull the top element from the container which is 2. It represents the key to room number 2. Then I jump to room number 2, and here I can see that I have the key to room number 1, and that I already have in my pocket, which can be verified from this visited array. And then that means I do not have to pick this key. So I mark my room number 2 as visited. So the room number 2 is unlocked and it has been visited, and I end up with the empty container. So this container is empty now, and all the rooms that I have, that are 4 rooms, has been visited. So all rooms has been visited. That means we could visit those rooms starting from key 0. Therefore the answer to this for this particular test case would be true. So that's the strategy to solve this problem. We start from room number 0, we push it into a container and we mark its presence into a visited array. Then we pull it out or pop it out and we unlock this room, that is room number 0, and we pick the keys from that room and push them into our container. and the process continues for other rooms as well. Fine, so that's how we solve this problem. Now the question is, which type of container or data structure can be used to hold the keys in this fashion? Observe that this container holds the keys in a LIFO order, that is last in, first out. And we know this type of functionality is supported by the stack data structure. So I use a stack to hold my keys. So let's see the implementation for the approach I explained here. So this is the implementation. This is the function can visit all rooms function. So which takes in the rooms array, and first we calculate the size of the rooms array. Then I initialize my visited array of the same size n, and I mark the presence of key number 0 into this array. That means I have the key to room number 0. Then I declare a stack which will be used to hold the keys, and I push the key number 0 into our stack. Then I run a while loop, and till the stack is not empty, I pop the top element from the container or stack. Then I iterate over the elements into this room or into this room, that is node. So this represents the key number or the room number, and that room number holds some keys, and we are iterating over those keys. So here I'm checking if I do not have that key into my visited array, then I push that into the stack and I mark that as available in my visited array. And in this fashion, I try to visit all the rooms as per according to the keys which I take out from this stack. Fine. Finally, I'm iterating over the visited array here, and I'm checking if all the rooms are visited or not. That means all the keys are present in this visited array. If it is not the case, if some key is not present, then that means I return false, otherwise I return true. So this is how this function is working. Let's see the time and space complexity for this solution. So we can see that this is nothing but depth first search. So this is just a depth first search approach to solve this problem. So how this is a depth first search approach? Because initially I have key number 0 in my hand. Then from this key number 0, I can move to room number 1, and I can move to room number 3. Then from this room number 1, I can move to room number 2. And from this room number 3, I can move to room number 0. So this is what this array is representing here. And I'm starting from room number 0. And I'm asking whether I can visit all these nodes or not. That's what I'm asking. And standing at room number 0, if I have the keys to room number 1 and room number 3, only in that case I can visit this room and this room. Otherwise I cannot visit these rooms. So this is just a depth first search that we are performing here, and the depth first search approach takes big of n plus e time complexity, where n represents the number of nodes and e represents the number of edges, while the space complexity is big of n, that is the stack space and visited array, while the auxiliary space is consumed by this visited array only. While the space complexity is linear because I'm using an auxiliary stack and an auxiliary array. So I'm explicitly using a stack to store the nodes and to process them in the order in which we want. So that's how the solution works. Let's see the implementation for the approach explained here. So this is my solution class, and in this solution class I have can visit all rooms function which takes in the rooms array, and initially I'll calculate the size of the rooms array. Then I declare my visited array of the same size. Then I declare a stack and I push key 0 into the stack while marking this key as available into our visited array. Then I iterate till I process all the keys in the stack. I pull the top key from the stack, and then I go to the neighboring nodes for that particular room. So I jump to the room for which I have pulled the key here, and I go to the neighboring rooms and I check if if a particular room is not visited. Then I mark it as visited and I push it into the stack. Fine. So here I am picking up the keys from that particular room. Finally, I have to check whether I have visited all the rooms or not. If they are not visited, then I'll return false right from here. Otherwise return true. That means I have successfully visited all the rooms which we have, starting from the room number 0. So that's the solution in C++. Let's see the solution in other languages. So this is the implementation in Java language, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.